We are live on YouTube now. Prof. K.
Yes.
Want to share from your end?
Well, I don't have
so that you have the control, so that you can advance your slides.
Okay, no problem.
Right?
No problem. Let me do that.
Okay, I'm going to stop sharing now. Then you can share, and I believe there's no much time delay between us, apart from the 6 hours time difference. Therefore, I think it should be about 9 o'clock on your end, right? Therefore, we can start. Yes, I will start recording now.
Okay. Okay. I wish to welcome everybody. Good afternoon for those in Nigeria. Good morning for those, and good evening for those who are in other places as well. You're welcome to this special seminar that is the result of a collaboration that is sponsored by the Carnegie African Diaspora Fellowship Program, CADFP. And during the next 1 hour or thereabouts, we will be discussing the specifics of this Carnegie Fellowship that we're on, and we will look at the various benefits of being in this special fellowship. But before we even start with the presentation, okay, before we start with the presentations, I wish to inform those who are present that there are 3 different universities involved. From the fellows side, there is the College of New Jersey in the United States. And then on the part of the Nigerian universities involved, there is Obafemi Awolowo University, Ile-Ife, Osun State, Nigeria. And there is also Elizade University in Ilara-Mokin, Ondo State, Nigeria. And each of these universities has some representation that will be involved at some point or the other in this program. I want to check to see how many of the deans of the respective institutions are around. I believe the Dean of the Faculty of Engineering, Elizade University, Ilara-Mokin, Ondo State, Nigeria, is available. Professor
Available.
Masoge, you're most welcome.
Thank you very much. Thank you.
Yes, sir. Please, can you make some comments within the next 2
minutes? I want to say good afternoon, everyone. And yeah, I just want to appreciate the organizers and those attending this visual seminar. I want to also use this opportunity to thank everybody on board. And it is our belief that such initiative as this would go a long way in fostering research collaboration amongst our universities in Africa and universities abroad. I want to especially thank Dr. Ogumba and Dr. Razak. I can see Ambrose Adegbige. I think I know you somewhere. Just to appreciate you all. Thank you. And this is a good initiative. Thank you.
Thank you very much, Professor Masoge. We appreciate it. I believe that, well, the other deans will join us as the presentations progress, and as soon as we can accommodate their comments and contributions, we will do so. But without any further ado, I want us to begin with the first presentation by Engineer K.S. Ogumba. That's my humble self. The title of the presentation is the Teacher-Scholar Model. And as we go along, you will appreciate exactly what this fellowship is about and how also we can continue to foster this kind of relationship so that many more universities in Nigeria and beyond can be involved in the future. So a teacher-scholar model, within the next 10 minutes or thereabouts, I'll try to go through these slides. The teacher-scholar model for embedded control, the nexus of collaborative research, innovative pedagogy, and scholarship. And in my short presentation, I will just give a background to the fellowship, and I will talk about what inspired the fellowship about 7 or 8 years ago, and what it has been able to achieve, and then what this specific fellowship is about. And then subsequently, Dr. Razak O. Alioke will make a presentation on the technical aspects of our fellowship. And then subsequently, Dr. A.A. Adegbege of the College of New Jersey will talk about the prospects of such fellowships in the future and how people of different types within and outside the university community in Nigeria and abroad can key in so that our respective university programs can be improved significantly. Now, to the background, I don't know if you can see my slides well, but you see, there is obviously a need to advance the different programs taking place in African universities. There are challenges in different universities in terms of manpower, in terms of facilities, in terms of expertise, and so on. Many people, for instance, prefer to work in the industries after school, and the academic enterprise in Africa has suffered from brain drain and all kinds of phenomena that continue to make us to be a bit weaker than perhaps we were a couple of decades or so ago. And we know that American universities, universities in Canada and places of that nature are some of the best in the world. Based on every metric one can think of, they turn out the highest grade of scholars, they turn out people in industry that are championing the new wave of civilization, artificial intelligence, and so on. And so, of course, a collaboration between those universities will benefit both parties, because on the part of the hosts, of course, we can gain from the knowledge and experience and capabilities of scholars from or based in the USA and Canada. And on the other hand, too, those in the USA and Canada can get to appreciate the wealth of talent that African universities have and can help us to find reasons to collaborate and even improve on their own research aspects as well. And so the result of the collaboration is part of what we are discussing today. And I have listed a few of those benefits here. The abilities to train students in a wide variety of fields. I mean, all we need to do now, if there is sufficient collaboration, is to set up virtual classrooms, virtual meetings, and somebody in Australia or somebody in another part of the world can actually teach our students here. And so the geographical barrier is considerably removed. Teaching methods can be improved. As teachers, we can improve on how we teach our students to make them learn better. Curricula of different universities can be made to go according to the trends that we know are shaping the new phase of civilization. And there can be scholarly interactions. Scholars in different parts of the world have very similar characteristics. We are all thinkers and so on, but we may be limited in resources and the likes. And there are great ideas that can come from Africa. Many incredible ideas are in Africa. And so that exchange of ideas is beneficial to both parties. And ultimately, both our immediate and our global environments can be greatly enhanced by these collaborations. Student exchanges also can be enhanced. We can have situations where people go on trainings in universities from one host to another host, or from host to a fellow institution. And there are so many other things that can come from this. And that is the reason why the Carnegie Corporation of New York in 2013 began to sponsor this initiative to bring African scholars based in the USA and based in Canada, even into African countries, since they perhaps understand the terrain, the language, and so on better. They can even interact better, and then provide platforms for even more collaborations between the host and the fellow institutions. And this is what has given birth to this particular initiative that we are discussing today. And of course, as I said, it's a mutual relationship. The host gets to learn from the expertise of the fellow, and the fellow also gets to interact and even gain knowledge and facilitate interactions even among these institutions. And so the CADFP, the Carnegie African Diaspora Fellowship Program, was birthed, as I said, in 2013, and up to 527 different fellowships have been awarded. And it has continued to thrive. More and more institutions are coming on board. And we came on board, we put our application in June 2020 during the pandemic, and we were successful. And now it is bringing benefits to both, or the three institutions, Obafemi Awolowo University, Elizabeth University, and the College of New Jersey. And we hope that with this particular presentation, it is revealed to as many scholars and students in different universities in Nigeria that this is actually possible. There are many other fellowships that can be embarked upon. And ultimately, we do not need physical presence for things to be improved in our universities anymore. So I've said that the CCNY, the Carnegie Corporation of New York, has sponsored this, and it is coordinated by the IIE, the Institute of International Education in the US. The fellow in this case is Dr. A.A. Adegbege of, I'm sorry, let me make it a bit clearer. I don't know if you can see better now. The fellow is Dr. Adegbege. He's an associate professor at the Electrical and Computer Engineering Department of the College of New Jersey in the United States. And then we have two hosts. My humble self, I'm in Electronic and Electrical Engineering at Obafemi Awolowo University. I'm one of the hosts. And then the second host is Dr. Alioke of Electrical Engineering of Elizabeth University, Lamoke, in the state, Nigeria. And the specific areas that we have decided to focus on is embedded control. And I've tried to put it in very simple language, that there is something called control engineering, the infrastructure put in place to make sure that we can achieve desired results in different machines, in simple language. And it is mathematical, but then it can be put in boards, in computers, in chips, so that whatever we teach in theory can be transmitted into practical systems of any and every type. And so this particular endeavor is meant to foster collaborative research between the fellow and the hosts. It's also supposed to develop a PG curriculum in embedded control for both host institutions, so that not only are we collaborating to do research together, the three of us, and bringing in our students and staff in affiliated areas, we're also developing a curriculum so that the university can begin to do new things and go
recording in progress
in technology. So this is as much as I will say now. I will now invite Dr. Razak O. Alioke to speak on the specifics of the collaboration that we have had within the period that this fellowship has started and the fruits that have been able to come out of it. And after he has spoken, Dr. Adegbege will give us highlights of what can happen and what ultimately will happen as far as this fellowship is concerned. Thank you very much for listening. Now I hand over to Dr. Alioke. Thank you.
Engineer Ogunba, can you stop sharing?
Yes, I have stopped.
Okay. Yeah, thank you very much for the wonderful presentation. Coming.
You may need to unmute yourself.
Okay, sir.
Are you there, Dr. Ali? Okay.
Yeah, I'm trying to share my slides, but it's not
Okay.
getting.
Yeah, it's unmuted now. Okay.
How do I proceed, Professor Guba?
There's a green button below on the Zoom screen.
Oh, yeah, I got it. Yeah, thanks.
Okay. Okay.
Thank you very much, Engineer Gumba, for the wonderful presentation. I'll be presenting our collaborative research work titled A Static Anti-Wind-Up Synthesis for Internal Model Control. This is the outline of my talk. The first section discusses the background to the problem we are aiming to solve. While the sections on analysis framework and main results presents our proposed solution. Finally, we demonstrate the effectiveness of our proposed anti-wind-up control structure using benchmark examples. All systems of practical interest typically involve some kind of nonlinearity, and a very common one is the saturation constraints. What do I mean by saturation constraints? This implies that your device or part of your device or your system as a whole has a limited operating range. You cannot operate it beyond a certain range. For example, you can consider your DC motors. There's a maximum speed at which your motor can operate. You can't operate your DC motor beyond the maximum speed, and the maximum speed usually indicated on the nameplate of the motor. Similarly, for your digital to analog converters, which is typically found in data acquisition systems, it has a limited output. It can't go beyond 10 volts, for example, and if it's a 0 to 5 volt scenario, it can't go beyond 5 volts. This limited operating range affects the performance of our system. You can't compare a system where your actuators can work on an infinite range to the performance where your actuators, such as your DC motors, can operate within a limited range of maybe like 0 to 250 RPM. There will definitely going to be a performance degradation when saturation constraints are met. And sometimes this might lead to instability. And a very famous example is the Chernobyl disaster, which is quite a long time ago. Now, what do I mean by performance degradation? There are typically two kinds of performance degradation you would normally expect when you have saturation constraints. You either have the wind-up effect or you have the directionality problem. For the wind-up effect, what really happens is that there's a mismatch between the controller outputs, U here and the plant inputs U hat here. And once there's this mismatch, what effectively happens is that there's an open loop here. The loop is broken at this point here, and as a result, your closed loop feedback is no longer a closed loop, it's now an open loop. And of course, you will lose the advantages of closed loop feedback when this happens. And this is what leads to your performance degradation, because typically you are just in open loop. And if you look at the right-hand diagram, which is in figure 1.2, the red response is response when you don't have any saturation constraints. That means that your controller outputs U is essentially the same thing as the plant inputs U hat. You have no saturation constraint. In that case, you have a reasonably good response, which is the red plot. On the other hand, when saturation constraints are activated, in that case, where there's a mismatch between your controller outputs U and your plant inputs U hat, what happens is that you have an extended overshoot, an indication of performance degradation. That is the blue response. And to address this, what we normally do is to have anti-wind-up implementation to address the problem of wind-up effects. And for example, when the anti-wind-up mechanism has been implemented, what we have now is a green response. You can see that the overshoot has partially been eliminated in the green response. That's because of the anti-wind-up implementation, which has been used to address the wind-up effect. And what do I mean by the wind-up effect? A mismatch between the controller output U and the plant input U. There are two approaches in addressing this wind-up effect. One is the posterior approach and one is the a priori approach. The a priori approach implies that you consider the saturation constraints. You consider it while you are doing the control design. It's implicit in the control design methodology. That's a priori approach. An example of that is your model predictive control, which is very, very popular, the model predictive control. On the other hand, you have the a posterior approach. In the a posterior approach, what you do is that you design your controller without taking saturation constraints into consideration, in the sense that you design a linear controller, ignoring the saturation constraints, ignoring that there's a saturation block A, design the linear controller. After doing that, then you now implement an anti-wind-up compensator to mitigate the effects of whatever performance deviation that might occur due to the wind-up effect. It's like a two-step procedure. Design the linear controller, then design the anti-wind-up compensator. The controller structure I'll be discussing in the next slide is a very common example of the a posteriori approach, where you have a two-step design approach, and the controller is the IMC controller, internal model control. What you have on the left-hand diagram, that is figure 2.1, is your standard IMC control, where there are no saturation constraints. You typically have your G of S, which denotes the transfer function of your plant. Then your Q of S denotes the transfer function of your IMC controller. On the right-hand side, we have the anti-wind-up implementation of the IMC control. The one on figure 2.1 does not account for any saturation constraint. It does not anti-wind-up. The one on figure 2.2, which is right-hand diagram, has the anti-wind-up implementation. And if you observe the difference, if you observe the two diagrams, what you observe is that your IMC controller Q has simply been factorized into Q1 and Q2. And that is what we call IMC controller factorization. To be able to implement your anti-wind-up, what people typically do is to factorize this IMC controller and factorize it into Q1 and Q2 in the manner shown here. And another thing I need to point out here is that why is the IMC structure attractive for anti-wind-up design? One of the reasons why the IMC structure is attractive for anti-wind-up design is because of the transparency of the design process. The design process for IMC, internal model control, is very, very transparent. And moreover, other controller structures can easily be transformed into the IMC structure. Now, we move on over to this is the IMC anti-wind-up structure. You can see the controller factorization. These are Q1 and these are Q2. So this is the anti-wind-up implementation of the IMC, where U is the controller output, and V is the plant input into your plants. And when you have saturation, what happens is that there will be a mismatch between U and V, effectively breaking the loop of the loop of the closed loop. In literature, there are a number of existing IMC factorization already. We have the one of Wu, which is also an interesting factorization, but the difference is that for the Wu factorization, it doesn't consider the true anti-wind-up goal. While for the rest, which is Godwin et al., Campo Amorari, and Zeng et al., one thing that one characteristic of all the rest is that it's heuristic. The factorization is heuristic. There are no systematic approach to actually do the factorization, but based on heuristics and understanding of the system, they are able to come up with this factorization, which has proved to be reliably very okay. However, what we are interested in is, can we obtain an IMC factorization that includes some of the above as special cases? Instead of us having an heuristic kind of approach in just choosing any of these listed IMC factorization, let's have a systematic approach that would give us either of these cases, depending on this as the situation demands. That's what we aim to solve with our research work. Now, to be able to do that, we need to define a framework with which we'll be able to do our design process. And this very slide or this very section will be discussing the analysis framework with which we base our work upon. So suppose we have a dead zone nonlinearity, which is defined by DZ, as that's a dead zone nonlinearity, such that our saturation, the output of our saturation and the dead zone simply gives us the inputs, the desired inputs. Basically, what we are saying is that the dead zone is simply an additive inverse of your saturation. When you combine them together, it gives you the original input, which is our U. So let's assume we have that kind of a nonlinearity. With that in mind, our anti-wind-up implementation, which was shown in figure 3. This figure 3 can be reduced to this particular figure here. That is, they are actually equivalent. This figure here is equivalent to the previous figure. And here we can see clearly the demarcation between the linear loop. This is the linear loop. One at the lower part is the linear loop, which is the typical standard IMC control. The upper part is our nonlinear loop, which is an indication of the mismatch between our controller output and the plant input. It's an indication of the saturation constraint being active. If the saturation constraint is not active, that means this nonlinear loop will not be there. you simply have the lower one, which is the linear control. But when the saturation constraint is active, that causes this nonlinear loop to go in effect. And as a result of that, which you can see in your YD here, it will affect the performance of our outputs here because of that nonlinear loop. So based on what we have in figure 4, suppose we have that assumption there. Then from this figure 4, we can write out this equation as an equation 1, which essentially says that Y, which is what we are saying here, is simply what? Y lane, that's the linear part of the output, plus YD, which is due to the nonlinear loop, which is what we have here. Y is simply Y lane minus YD. And on the other hand, our control, which is U, the actual control, which is U, is simply the U lane, the linear part of the control, plus UD, which is due to the saturation constraint. So in the absence of saturation constraint, what you simply have is Y is equals to what? U lane, and U is equals to what? U lane. In the presence of saturation constraint, which causes performance degradation, what you have at the output is Y lane minus YD, U lane plus UD. So the aim of this work is to try and minimize this YD. That is for a given UD, for a given U lane, which is a linear control, for a given U lane, let's minimize this YD. By so minimizing this YD, we are reducing the effect of the nonlinear loop on our output Y. So the aim of this work, as I repeat again, is to minimize the value of YD for a given U lane. Okay, so in order to be able to achieve that goal, achieve the goal of minimizing YD for a given U lane, we need to have some descriptions to describe our system parameters. We all know what G is. G is the plant of the system, Q is the IMC controller. Let's suppose we define this, we define G and Q by this state space description, where this is your A matrix, the normal A, B, C, D matrix of your state space description. This is your A matrix, this is your B matrix, this is your C matrix, and this is your D matrix. Ditto for Q. Let's go further again and consider this particular factorization scheme. We mentioned earlier that we want to factorize our IMC controller Q. We want to factorize our IMC controller Q into Q1 and Q2. What we are doing is that we are factorizing it in terms of a particular static gain matrix lambda. These are static gain matrix lambda, is a matrix. So we're going to factorize this Q of parameterize this Q in terms of this static gain. So we know our Q infinity, which is the steady state gain of our Q. We know what our Q is. So in terms of this static gain, we can parameterize what Q1 is and also parameterize what Q2 is. So at the end of the day, we are trying to find a suitable value for this static gain matrix lambda here. So once we get that static gain, once we get the static gain matrix, which is this lambda, we're able to obtain our Q1 and obtain our what? Q2. So based on this state description that we have described for G and Q here, we know that our Q1 will be given by this state space description, where we have our AQ, BQ, DQ, CQ. Everything is known except for our static gain matrix lambda, which is the unknown we are trying to look for. Similarly for Q2, we have this state space description. Finally, we now look at the perturbation terms, the terms due to the saturation constraint, which I talked earlier in the last slide. Recall that we are trying to minimize YD. So, but before you're able to minimize YD, you need to get the state space description for YD and UD. So going by equation 4, we have the state space description for YD and UD. So of course, this is the A matrix for YD. This is the B matrix for YD. This will be the C matrix for YD. This will be the C matrix for UD. Ditto for our D matrices here. It combines both the state space matrices of YD and UD together into this equation, into this item 4 then. Now, with that description and that understanding, we can now proceed to the main result, which is the synthesis of the lambda-tuned anti-wind-up compensator, which was shown earlier. But just to draw it in another fashion that is much more appealing, we have it drawn in this form, where you have your saturation here. This is your controller output U. And here, what you have is your saturated value, which is what is going to the plant. Typically, when there's a saturation constraint, your U here will be different from your saturated value of U or your V here. And the way we have parameterized this compensator is to determine a suitable static gain matrix lambda here. Once we're able to obtain this static gain matrix lambda here, we're able to obtain our Q2 here, and we're able to obtain our Q1, and that will yield our IMC parameterization. Now, to be able to proceed to the main result, we need to discuss some notation that we will come across as we go along. First of all, the diagonal is straightforward. It's the diagonal block matrix in which Y and M are the diagonal elements, and matrix inverse denoted as Y and M is as shown there. Then the other thing is the square matrix. For a given square matrix, you define your Hermitian X as the summation of that same matrix X plus the transpose of that matrix. The final one has to do with the matrix whose columns form the basis for the right null space of H. So we are considering, given a matrix H, we want to denote this symbol here as any matrix whose columns form the basis for the right null space of H. In essence, what that means that when you multiply this out, H times this matrix here, it will always give you what? 0. It will always hold. Now, let's state our results. Consider the anti-wind-up structure shown in the previous slide, that's our figure 4. Suppose there exists a feasible solution to the LMIs, which is linear matrix inequalities, which you'll see in the next slide. Suppose there is feasible solution to that LMI. Then there exists a static gain, this lambda here, for which the L2 gain of this map is less than lambda. What the last part is talking about is simply that for a given U lane, you want to find a static gain lambda here for a given U that minimizes the gain between U lane and YD. So that's what this result is telling us. It's telling us if we're able to get a feasible solution to the LMI 7, then we can be guaranteed that there exists a static gain matrix lambda, which we said we are looking for. There exists, we can be guaranteed that there exists this lambda such that the gain between the gain of the map from U lane to YD is less than a particular value, which is called gamma. Now we go ahead to now discuss the sketch of the proof. First of all, we have inequality 5, which is a standard inequality for stability of figure 5, in the sense that if inequality 5 holds, then figure 5, which is the lambda tuned IMC, which I showed earlier, is guaranteed to be stable with an L2 gain that is less than lambda. In summary, it just says that once this inequality is satisfied, then your figure 5 is stable. And it actually goes ahead to give us the measure by which it's actually stable. It's telling us that this L2 gain will be less than lambda. So how do we use inequality 5? That's the next bullet point. You choose the Lyapunov function, B of x, as indicated there. Using this Lyapunov function now, substitute inside inequality 5. You have your Lyapunov function and the derivative of it here. To substitute your Lyapunov function here, and with this substitution, carry out the following steps. Score complement lemma, apply some scaled variables, then do a congruence transformation with this particular diagonal block matrix. At the end of the day, what you get is that this inequality, which is 5, becomes a matrix inequality 6 that is shown here. And this is a matrix inequality that's in terms of variables y, m, the lambda we are looking for, and gamma. Recall that y and m, matrix y and m, are actually inverses of p and w respectively. So the summary of this space is that this inequality 5, is equivalent to the matrix inequality 6. In essence, that means if this matrix inequality is satisfied, if 6 is satisfied, then we are sure that figure 5 will be stable with an L2 gain less than lambda. So the work we need to do is to find the conditions under which matrix inequality 6 will be stable. Going to the next slide now. Going back to the previous slide, what we have in this inequality, this is a matrix inequality, fine, but we have nonlinear terms in this inequality, in the sense that if you look at the very first term here, there's a multiplication of 2 unknowns, then y and lambda. And when you have multiplication of 2 unknowns, you have a kind of nonlinear matrix inequality. And because of that, we will need to linearize this matrix inequality by invoking some certain lemmas. We invoke the projection lemma and the Finsler's lemma simultaneously. And with this invocation, we're able to convert that matrix inequality in 6, that nonlinear matrix inequality in 6, and convert it or reduce it to 2 linear matrix inequality. This is the first this is the first LMI, and this is the second LMI. So in essence, matrix inequality 6 in the previous slide is equivalent to the satisfaction of matrix inequality 6 in the previous slide is equivalent to the satisfaction of these 2 LMIs. As far as these 2 LMIs are satisfied simultaneously, that means the matrix inequality in the previous slide is also going to be satisfied. With that now, I need to call your attention to the fact that this matrix UA that you are seeing here is actually the matrix whose column form the basis, the right null basis of C naught of Y. I've already explained what this notation means in the earlier slide. So this matrix U is a matrix whose columns forms the basis, the right null, form the basis of the right null space of C naught of Y, which implies that C naught of Y, C naught times Y times U will be equal to 0, must hold. With that in mind, we observe that the results in LMI 7 is sensitive to the choice of our matrix U. Then to summarize all what we have done, we have this algorithm here, which is our construction, the algorithm for the construction. The first step is to solve the feasibility problem, which is that given G, Q, and our appropriate U, solve the optimization problem which minimizes gamma, the L2 gain, which minimizes gamma subject to LMI 7. LMI 7 are 2 LMIs. So you try and minimize this gamma subject to this LMIs in 7, and you're able to obtain the optimal values for Y, M, and gamma. The next step is now to construct the gain matrix, which is what we are really after. We need to construct the gain matrix, this lambda here. And to be able to obtain that, we will make use of the fixed Y, optimal value of Y here, optimal value of M here, and optimal value of gamma here. We'll make use of these optimal values and substitute it back into the matrix inequality in 6. With that now, we were able to obtain our gain matrix lambda. Having obtained our gain matrix lambda, which is that, we can now obtain our IMC factorization, which is Q1 and Q2, by substituting our lambda into the definitions for Q1 and Q2. Whatever you obtain for your lambda here, you substitute it in here, and you need to obtain our Q1 and obtain our Q2 respectively. With that, we have obtained the IMC factorization for the problem. Now we can now consider some examples to demonstrate the efficiency of our proposed lambda-tuned IMC compensator using some benchmark examples. We are going to consider 2 examples. For the first example, the lambda, the gamma that was obtained, that means the L2 gain that was obtained, is as shown there, and the constructed gain matrix is also as shown in 8. Similarly, for example 2, we have our gamma and our constructed gain matrix as shown in 9. The next 2 slides show the output responses, the plant output response and the controller output response of our simulation as compared to the other schemes under consideration. For the very first simulation example, we have this. The upper part represents the output responses. There are 2 output responses, and the lower part represents the responses due to the control signals. As you can see from output response Y1, we see that our the Campo response typically is very okay at the transient part. This is the transient part here, which is the red one. You can see it's relatively okay. In fact, it's better than all others, except for ours. And for the steady state aspect of the response, we can see that the Godwin performs better. So Campo performs better at the transient stage, the red response. But at the steady state stage, we have our Godwin, which is the black one, performing better. So you will notice that our own response, which is the blue one, actually is like a mix of both responses. It takes the good of both sides, in the sense that at the transient, it has a very good response at the transient, which is the blue one. It rises up very, very fast compared to all others. It's very, very much better. And at the steady state, it also has a very good response comparable to what Godwin. So like our alpha-tuned IMC takes the best of both worlds. which what we talk about is systematic approach in determining our what IMC factorization. We are not stuck with the Campo. We are not stuck with the Campo factorization. We are not also stuck with the Godwin factorization. We have chosen a factorization that takes the best from both worlds, and that's because we have a systematic approach in determining our factorization. Similar thing can also be said for the output response Y2, where we can see our blue response has a very good response compared to others, especially in the transient stage here. This is transient stage here. Then the steady state stage here is better than the rest and is close to that of Campo, which is the black one. You observe the control signals too. You see the signals for the Campo and ours. You observe the blue response and the red response. That is for the Campo and our proposed solution. They seem kind of similar, but even though they seem similar, you can see the significant difference in the performance in the Y responses, in the output responses there. Now we go over to the second example. The second example is even more, has a very significant performance. Our proposed solution has a very much significant performance in the second example. As you can see, the alpha-tuned IMC, which is our proposed solution, has a much better response compared to other responses. Though the alpha-tuned IMC response has a similar, which you can see here, has a similar response to the Godwin because they are actually overlapping. The Godwin and the alpha-tuned IMC actually have a similar response here, and they are both better than Campo and the Wu responses. Similar thing can also be said for the Y2 responses. Both the Campo response and the proposed solution is better than the rest. And one of the advantages of our proposed solution is that it has a systematic approach in determining the factorization. It's not as if it's stuck with the Godwin factorization. It's not as if it's stuck with the Campo factorization. If you observe in the first example, Campo was sort of better than Godwin. In this example here, we have Godwin better than what? Campo. So we can't be changing factorization from examples to example. That's where our own proposed IMC solution comes into place. Whichever factorization that is best, it's always systematically produce that factorization. And that's one of the key advantages of our proposed solution. Similar thing also be discussed regarding the control signals, regarding the significant difference in performance, despite the fact that they have similar control signals. With that, we have demonstrated the effectiveness of our proposed lambda-tuned IMC compensator. In conclusion, what we have done so far is to propose an IMC controller factorization that is the key one and key two that is parameterized by a single static gain matrix. Is a static gain matrix that would parameterize that factorization of Q1 and Q2. And we have achieved this by minimizing the L2 gain of the nonlinear loop. What do I mean by this? We are minimizing YD for a given U-link during saturation in line with the true anti-wind-up goal. We have also demonstrated that the lambda-tuned IMC yields an improved performance. Further work also includes generalized framework for IMC controller factorization. You observe our IMC controller factorization only sort of was able to get the responses due to some earlier cited factorization. We now want to look at the generalized framework that we're able to include more existing factorizations into the systematic framework that we have. Then the other thing we want to look at is an effective way of constructing a null space basis in a derived element. If you recall, I mentioned that the U matrix, which has to do with the null space basis, is the signal aspect of the LMI. And said that the LMI, the result of the LMI is sensitive to the matrix that contains the basis for the null space basis. So we need to find a more systematic or effective approach in being able to obtain that matrix U. And with that, these are my references that have been used for this work. And this is another slide for that. I think that will be all. Yeah, thank you for listening. Now I will now hand over to Professor Adegbege to give us the concluding part of this seminar. Thank you.
All right, thank you. Professor Adegbege, please take over.
Okay, thank you very much, Dr. Alioke, for that beautiful presentation. Can you stop sharing so that I can?
Yes, I will do that in a minute.
Okay. Okay, can you see my slide now?
Yeah.
I see your
Thank
slides.
you.
Yeah.
Okay,
Yes,
thank
we
you
can.
very much. And apologies, we are running a little bit behind time. Hopefully, we'll be able to catch up and allow some time for questions on both the technical aspect as well as the introductory part of this seminar. Excuse me. Okay, today I'll just kind of wrap up the basis for this fellowship program and looking forward. And I titled my presentation, the Teacher Scholar Model for Embedded Control in Nigeria. Basically, I'll be talking about three things. One, what is this Teacher Scholar Model? What is it? And number two, what is the embedded control course that we're trying to develop as part of this fellowship? And then finally, I'll just highlight how you can get involved. Some of you are here, you are students or you are faculty professors, and you are looking at how do I get involved in such an initiative like this? Or you are representing your university or you are like industrial specialist. Therefore, I will talk a brief comment on that. Now, what is the Teacher Scholar Model? Number one, most of us here, we are very, very conversant with what we call scholarship. Scholarship involves the discovery of, excuse me, my throat. Scholarship involves the discoveries or synthesis of new knowledge, and then the application of such knowledge to solve problems, to solve real-world problems. In fact, if you have been following, we have some engineering challenges of the 21st century. And some of these challenges involve reverse engineering of the brain, artificial intelligence, machine learning, data science. You know, we have all these challenges that is ahead of us. How do we solve it? We have to discover, we have to synthesize new knowledge to solve this persistence problem, to solve the problem of humanity, COVID-19, global pandemic. Therefore, we continuously research to discover, to generate, or to integrate knowledge, or to apply existing knowledge to solve practical problems. Teaching. Most of us are teachers here. We know how to teach very, very well. Therefore, teaching involves communicating this new knowledge and also creation of capacity for inquiry and innovation. While you are teaching, the reason why you teach is that you want to get your students to start thinking, to start, to start innovating, because you are developing future leaders, future engineers, future STEM worker, future STEM force that will impact, the next generation. Now, what is the Teacher Scholar idea? The Teacher Scholar model idea is integration of both teaching and scholarship within the same framework. And what does it entail? Teacher scholars, they pursue an active program of research and scholarship, at least for you to impart something. You have something that you are doing. Therefore, you have an active program or a research program that you are pursuing. And some of us are doing that, okay? You are doing your research. Now, the next part is that teacher scholars, they enrich their teaching. They enrich their student experience by incorporating insights from their research into their instructional activities. Therefore, you bring your research into the classroom. You bring insights from your research into your classroom. And then finally, teacher scholar, they promote deep learning approaches, not just cramming. We know how to cram a lot in Nigeria. Laplace transform, and you have to Beru, you have to cram everything and then go to the exam and then pour everything down. And after the exam, you ask them, but everybody forgets it. And it's a person who earns an A in that course. Now, how do we promote deep learning approaches? Deep learning approaches are the approaches that will bring about innovation, innovative thinking in students. And the teacher scholar also calls the conversation about new scholarship to take place in the classroom. You can see now you have a closed loop. You do research, you discuss new insight about your research in the classroom. the conversation in the classroom also engender new research that you will go, to go carry out in your lab. And with that, what you do is that when you come to a class and you discuss your research, you are also recruiting students. Now, students will develop interest in the particular research that you are interested in, and then they will sign up to do research with you. And it is those students who are also going to generate new results that will inform your new teaching. And then you go along and then you go in that loop. That is the teacher-scholar model. And that is the idea we're trying to exemplify in this fellowship. And in this fellowship, we're trying to create a course and use this teacher-scholar model to run that course, to demonstrate, to show that it can be done, and to see the lesson that we can learn from that initiative. And then we can share that with everybody as we are doing today. Now, why do we choose embedded control? Embedded control involves the use of specialized control computing hardware implanted within a larger system. And usually we have limited computational resources. If some of us followed the NASA, the helicopter, the Ingenuity that was launched, sent to Mars, you will see that they have limited resources on board. They have no much of computation power, limited energy. In fact, they have to allow the helicopter the solar panel to charge up for a few days before they could carry out the experiment. These are the challenges that we have in embedded control. Therefore, in embedded control, you have sensor data that is being acquired and processed real-time within the control, the embedded controller. And this embedded controller generates real-time data to actuate, to influence actuator. Therefore, this embedded control covers several fields. You talk about satellite system, you talk of autonomous systems, you talk of cyber physical systems, that comes within this framework of embedded control. And then number two, it kind of aggregates different knowledge base and discipline. You talk of computational mathematical programming, you talk of control theory, you talk of communication, you talk of power system, energy management. All those things can come within the framework of embedded control. How do we utilize this limited resource to solve problems? Now, this embedded control also gives a lot of opportunity for research. And that's why we're doing it. That's why we picked this embedded control course, that we're going to develop a course in embedded control to allow us to bring our research into the classroom and engage our students, and also, get conversation about this research to take place within the classroom. Now we can, since you have limited resources, you have, like Dr. Alioke mentioned, saturation can be an issue here. Lossy communication channel. Therefore, if you are interested in communication, how do you transmit data from the system down through the sensor to the controller? And how do you transmit your control signal back to the system? Therefore, you have losses along the way. How do you account for those losses? What about how robust is your system? And what about energy? How do you maximize energy? How do you store it? How do you dissipate it? Those are kind of questions that can come up in embedded control. Now, the embedded control course that we're looking at, which we're going to discuss details in our next seminar, we're trying to bridge the gap between theory and practice. Now, that course will entail, fundamental theory of control and embedded system. And we've been working, the three of us have been working, developing, fleshing out the details of this. Now, we want to put control theory. We want to put embedded system in content into this course, and it requires significant hands-on experience. Right now, we have been assembling modern equipment, or what I call it hardware, that will enable us to bring this practical hands-on experience into the classroom, so that the students, they are not just learning, they are also doing, and they are using modern cutting-edge tool to do that. And also, we want to expose them to to modern tool, software, and hardware. Now, looking forward from here, we want to take a leap into the future. Number one, I would say mark your calendar. There will be a second seminar, hopefully by the end of August, that we highlight, they will detail our efforts in this course, the curriculum development activities. And we're going to show you some demo, hopefully, of some of the things that we hope to accomplish in the classroom. Now, some of the hardware are currently being shipped in transit to Nigeria. And before then, hopefully, we'll be able to set them up and organize some kind of demo for everybody to see. Number two, we're looking at applying to another round of Carnegie African Diaspora Fellowship to support the teaching of those courses at the host institution. Therefore, we want to run this course, not just developing the course, we want to run it. That we want to run a version of the course at Elizabeth University, at Obafemi Awolowo University, and at the College of New Jersey here. That we want to run it, and hopefully, if we are successful in getting this second round of fellowship, we will be physically present to run the course at those host institutions. Now, how do we get involved? Which is my last part of my presentation. If you are here, you are a student, and you are thinking, how do I get involved? You need to sign up. Sign up to take that course at your university. You know, show interest. When you get the announcement that, oh, this course will be run next semester or next academic year, sign up to take that course. Number two, sign up to participate in embedded control research with your professor. Your professors are here. Therefore, after this seminar, talk to them. I'm interested in control. Can I come to your lab? Can I take a look at what you're doing in your lab? Sign up. That is the way you can get involved in this effort. As faculty fellows here, how do you get involved? Join the league, become a fellow or become a host. Host the Carnegie African Diaspora Fellowship in your institution. You know, sign up to be a host and host this initiative. Or you can join our consortium. The idea is that we want to create like a African, consortium, African-wide, and we are starting with the western part of Nigeria. We hope to expand and improve on the research network so that we can collaborate, share experience, and share expertise in different areas. Now, if you are interested, please join our consortium and then volunteer to host the CADFP at your institution. And if you are an administrator, you are a dean, you are a vice chancellor, you are here. What do? We want to advance university engineering education in Nigeria. How do you support that? There are a lot of initiatives like the CADEF, like the Carnegie African Diaspora Fellowship we are doing. There is still ARUA. ARUA is African Research University Alliance, something like that. And I'm really, really pleased to see that a number of universities in Nigeria are already involved in this kind of global network. And the idea is to pool resources and to put, pool competencies to leverage on what individual university already has to create, like a best practice for people to, and they support setting up center of excellence, at the different institutions. And I see that Obafemi Awolowo University is already part of ARUA. University of Ibadan is part of ARUA, and UNILAG. Those are the three universities in Nigeria. And I hope that you can advance your participation in this kind of network to advance engineering education in Nigeria. Also, you can explore opportunities for exchange program. Like I can send some of my students to OAU for a semester. Also, some students can come from Nigeria and come and take a course, at my university. Hopefully those can be worked out. If you set up your advancement office, you have an office in your institution that does, advancing, and you can explore all these opportunities for exchanges. You can apply for Fulbright scholarship or scholars. You yourself can be a Fulbright scholar to visit other universities abroad, or you can host Fulbright scholar that will come to your university and spend an academic year to have exchange of ideas and opportunities. That is about my presentation today. I want to thank you and to remind you that control is ubiquitous. It's in everything. It's in your cell phone. It's in everything you see around you. Control is interdisciplinary. It's mathematical. It's electrical. It's mechanical. It's industrial research. It's chemical. It's civil. It's interdisciplinary. And then control can change the world. control right now. We are using control to solve the pandemic problem and so many other problems that confront humanity. Control can play a role if all of us can put our hands on deck. Thank you very much. I will now give room for Engineer Ogumba to wrap up and take questions.
Thank you very much, Dr. Adegbege. And also, of course, thank you to Dr. Alioke, who gave the one before. We appreciate the content. We appreciate everything you've done. And now we want to go into the question and answer session. Please, if you have, I've already sent a message. If you have any questions, you can let us know. Just before that, though, the representative of the Dean of the Faculty of Technology has told me that he'll join us in a few seconds, but then perhaps we should take the first question. And once we do that, after that, perhaps the Dean would have arrived, the representative of the Dean would have arrived. Please, do you have any questions that you wish to ask any of the three presenters?
Mine is a comment. Hello?
Yes, sir.
Mine is a comment. Hello?
Yes, sir. Yes, sir. We can hear you, sir.
Comment. I think the comment is how we get to extend the benefits you have just mentioned, which are quite okay. And I want to also tell you, hello, can you hear me? Hello?
Yes, sir. Yes, sir. Can you hear us, sir? We can hear you, sir.
Yes, there are some platforms, even in Nigeria, that we want to really, apart from the university system, that want to leverage on this initiative we have talked about. This fellowship is really a good one. And I know some of our graduate students will be interested, and Alioke, we tell you more about this when you meet, that niche initiatives like this will benefit students, particularly graduate students, and we need to reach out to them. It's a way of collaborating. But we know that the problem students have is that of being able to reach out some of these things, get their solutions to some of these problems they may be solving. This is one channel I think can be worked out to have this thing. And I know now that being a control something, an environment that you can actually transmit information and all those things, some of graduate students, particularly our junior lecturers, want this information, particularly when they're doing their lecture delivery. So because I like the way presentations are made and so clearly, and I think some of these ideas can be put together and see how can get graduate students and junior lecturers on the platform. Thank you very much. I appreciate what has gone on. And I think we also have a problem here that if you say on Zoom, it's 1 hour, it's 1 hour, and you are cut off. I'm just looking that this time is not being cut off. Thank you.
Yes.
Yeah.
Thank you very much, sir.
Okay.
Well, yes, you've made a very important point. A lot of graduate students are either unattracted to graduate research work in Nigeria or in African universities because of a host of challenges, reaching out, maybe personnel, maybe equipment, maybe reputation. Maybe some people feel they will spend 10 years on a program, whatever. But the thing is that increasingly now with virtualization, with technology and so on, it's possible to bring so many scholars down or operate beyond geographical space. That means that really you can get just about as good the quality of education, even at any level, just based on having fellowships and having exchanges and having things like that. So it's an eye-opener. It also was an eye-opener for me when I got informed about it last year. And we hope that this will open many eyes so that people will begin to know that when somebody leaves an institution, it doesn't mean it's the end of the world for the old institution. It just means it's an opportunity for somebody to develop and then pass on that development to others in fellowship programs. And I'm sure that beyond CADFP, beyond ARUA, there will be many more that are around that we will discover. There are many more that are already in existence and will still come into existence, so that all our universities can begin to move up in terms of quality of delivery. Thank you very much for that comment. I don't know if the fellow and the co-host want to make comments as well.
Yeah, I think you answered it very briefly. The only thing I just had is that the graduate student mentoring is one of the pillars of the Carnegie African Fellowship Program, that the fellow will come and mentor. But you know, the problem we have is that it's a time-limited initiative. Therefore, the fellow can't spend 14 days or spend. Now, what we have done is to take advantage of this COVID-19 and extend, we have done, we extended the scope of the fellowship. But typically, you have a fellow that comes and spend only 2 weeks or maximum of a month. And during that period, he's supposed to interact with graduate students and provide some mentoring. Therefore, I think it's captured within the Carnegie African Diaspora Fellowship Program, which we can take advantage of for the next round or the next cycle of it.
All right, thank you very much, Dr. Adegwege. I see a comment here. Thank you so much, everyone, for this program, and in particular, Prof. Ambrose's representation. I'm happy I created the time to listen. My questions are 2 but short. Number 1, could you still keep us informed about next presentation like you did for this one? Number 2, is there postdoctoral opportunities in this collaboration? Thanks. That's from Mr. Ojaduku. I don't know if it's male or female, but thank you for your questions. Do you want to give an answer, Dr. Adegwege?
Yes, like I announced during my presentation, we are working on the second round of presentation, hopefully to be in August, and we will publicize it like we did for now. In terms of postdoctoral collaboration, yes, it's a possibility. I would say stay in touch with the co-host and myself. We can work that out.
All right, thank you very much. Looks like questions are few. Is there anybody else with a question? You can ask verbally or you can type. I'm still awaiting Dr. Ilori, who incidentally is also a co-host and the representative of the Dean of the Faculty of Technology, Obafemi Awolowo University. He expresses his desire, but I think he's also engaged somewhere else. I don't know if we should wait a bit or just have some little interaction while we wait for him, or perhaps we should just round off and tell him that, or I inform you that he passes his best wishes to us, because we are already beyond 3 o'clock that we wanted to end.
Yes.
Okay, well, any more questions? If there are no other questions.
Can I just answer? I just want to know, my name is Akinwumi Amushan from University of Lagos. So I would like to know, how can someone become a co-host, for example, in our department? So,
which department are you, sir?
From electrical electronics engineering.
Okay, maybe Dr. Adegwege can speak, and then maybe I'll just add a few comments after that.
Yeah, actually, the African Diaspora, the Carnegie African Diaspora Fellowship supports to have like a multi-host. Like that, if you want to be part of this consultant that we already have in place, we can expand the number of hosts for the next round. Therefore, if you are interested, I think you can get in touch with us. We can work that out. Hopefully, the announcement will come out next year, January. That will be the time you can keep your eyes on that as well. Therefore, you can, and the process is so seamless that you can, if you have a particular fellow in mind, you can write an application targeted specifically to that fellow. Or if you don't have any fellow in mind, you can just submit an application that, oh, I want a fellow to visit my university. This is the kind of things I want to do. And what the program does is to match fellows and hosts together. and if there is no match, then they will inform you, right? But usually what we did for this case is that we already identify ourselves, we already agreed to work together, we already define the problem that we want to solve, and then we put up an application jointly, and that application was approved. Now, for the next round, we can definitely expand to UNILAG, which is one of the vision of this consortium, is to continue to expand and to include as many universities as possible.
All right, thank you very much. And if you're, as Dr. Adegboge has said, you don't have to limit yourself or look down on yourself. If you put in a good application in consonance with a fellow, that also can show, because it's about quality of presentation and what your institution is ready to offer to support the fellowship. I think that if you put in a strong application, it will be taken irrespective of how disadvantaged you may think you are. So we are all encouraged to try. You don't do something unless you dare. Try. The worst that can happen is you fail, you try again, and ultimately you will succeed. Unfortunately, Dr. Ilari is not here, and I think we should just wrap up this this seminar. Let me just give a small vote of thanks. I want to thank everybody that has spared time to make this seminar at reasonably short notice. I unfortunately can't identify too many people, but I can see Dr. A. Bamimore of the Department of Chemical Engineering, also a control guru himself. I want to thank you for being around. I saw Dr. Kamal Oladipo of the Department of Civil Engineering, Obafemi Awolowo University earlier as well. I think he has left now. I just want to thank you. And unfortunately, I see so many names, I can't run through all of them.
I saw Dr. Ogedengbe, I think it's from UNILAG.
Yes, yeah. Dr. Ogedengbe from Temitayo from UNILAG, Engineer Lunge, Francis Moran, and so on. I'm sorry if I omit your name, it's unintentional.
Elizade.
They are from Elizade.
Yeah,
I am so sorry. I am so sorry. Just my sincere apologies. I want to thank you for your sacrifice, for your time.
You too.
Yes. Okay. Hopefully, for the next presentation, we'll see you again, and many more. Hopefully, all of us at some point can meet and collaborate to do great things so that our country can become a better place. I strongly believe that we can get the best from us, even in spite of the climate of disruption and problems that we seem to have in Nigeria. We can still do a lot of good things. So once again, I want to say thank you. I want to especially thank the fellow, Dr. Adegboge. I want to thank the co-host, Dr. Ali Oke, and everybody else that has been around. We look forward to seeing you
in the comment section.
Oh, okay. Oh, I'm sorry about that. Okay,
yes,
let me just...
Yes, the presentation is recorded. It's recorded on Zoom. If you drop your email, and I will also say the same thing with Akinwumi Amusan. If you drop your email in the chat, we will send the presentation to you.
Yes, please. I have dropped my email address in the chat. If you need these presentations, you can mail me. We'll arrange to mail you the presentations. And if you also need to chat, you can also use the mail option. We can respond as the needs arise and so on. So feel free, it's a collaboration, so we'll interact and we'll get the best from one another. Once again, thank you very much for your time, and please have a great remainder of the week. Thank you.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Yes, sir.
Obina Ojaduku, I think they came to share up Dr. Ali Oke.
That's good. That's good. My own students will have come too, but they have a 2 to 4 lecture, unfortunately. Yeah. So, but hopefully in the next We will
And
have
there was
more
one Dr.
people.
Oguye that joined earlier. We didn't recognize him, but yeah.
I assume he's the son of the eminent Prof. Ogunye.
Oh,
I assume
okay.
so.
Oh.
I am not sure. I wish he stayed a little longer so I could even get some comments from him. He's a very diligent member of the Society for Automation, Control, and Instrumentation.
I see.
Thank you. In any case, nobody is small. We appreciate we
Yeah.
appreciate everybody, and we thank you very much.
Yeah.
So
Dr.
I think we
Imahi?
can. Yes, maybe I should. I think it's an opportunity to.
Yeah.
Okay. Somebody is dropping an email address.
Okay.
Let me see if I can multitask.
Before,
here.
I will keep it running so that you can capture
Okay.
the comments.
Okay.
Yeah. Yeah. Because if I stop it will be deleted. Yeah.
Okay. That's unfortunately, unlike some of the other social media platforms, this one seems to erase whatever.
Yeah, it raises comments.
Once you're off. Okay. Let me see if I can. If I were using my laptop, I would have just copied and pasted. But okay, let's see what I can do. Or if somebody can help.
Yeah, I'm going to stop recording now, but just go ahead. I'll stop recording.
Okay. Okay. Thank you.
Yeah.